So let's start the topic. In today's session, we are going to discuss about the. In today's session, we are going to discuss about what is distance and how it is different from displacement. We also will find out what is the speed and what is the velocity. We will solve a numerical and end this video. So let's move to the next topic, first topic of the session, which is distance is the length of actual path traveled. So actual path, whenever a body is traveling, so what is following, that is that actual path, that actual length which he covered would be the distance. For example, let us say I have a, so he is traveling towards east direction. So he traveled 10 meter towards east direction, and then he take a turn and travel 20 meter towards the south direction, right? So I would say what is the distance traveled by a. So the distance traveled is equal to 10 plus 20. Okay, so this is the displacement. It would be distance, it would be 30 meter. Okay, so the actual path followed, that is your distance. Now let's come to the displacement. So displacement is the shortest distance. Okay, the shortest distance between initial and final position of the body, right? um, in a known direction. So it also contains direction, it also has the direction in it. So it is basically a vector quantity, it is a vector quantity. And distance is a scalar quantity. We know that scalar has only magnitude and vector has magnitude as well as direction also. So in distance, it is scalar which has only magnitude and no direction. But displacement, if we talk, it is a vector quantity, it has magnitude as well as direction. We also have to specify direction. So displacement is basically shortest distance. Okay, the shortest distance between initial and final. If you see, like in the previous example, if A is traveling towards 10 meter towards east direction, and then in the south direction it is traveling 20 meter. So what would be the initial and final position? So he starts from there and final position is this one. So this is the shortest distance, right? This is the shortest distance. So I can say that the displacement is this distance. Okay, when you find out 10 square plus 20 square root, that would be your displacement in this case. Okay, so that's why displacement is the final to initial position. Okay, or I can say that displacement is equal to the final minus initial position. This would give me displacement, the net displacement. Okay, now let's see in this picture. If you see, there is a rider which is traveling in this direction, and he is going to the factory. He is taking this route of the road and reaching at the factory. So the actual distance covered, this is the this is your distance. And the shortest distance between the rider's house and factory, it is this direct line we can connect. So this is your displacement. So displacement give you a direction, like from home to the factory, towards the factory it is 120 meter. And what he is actually riding, the way he is going, that actual path would give you the distance, and distance has no direction, right? Now, can you solve this for me? Can you, in this, here is a boy at position A. He goes to home and then goes to point C. So, can you tell me what is the distance in this case and what is the displacement in this case? Can you solve it to me? Now, let's see the difference. So, we studied that yes, the length of the path actually traveled, that is distance, and the shortest distance, which is initial position and final position, that is your displacement. It is a scalar quantity. Yes, we have seen that it's a vector quantity. Distance is measured is always positive. Yes, it is always positive, but displacement can be positive, negative, or sometimes zero also. So how it can be negative and it can be zero? So let's find out. Like, if A is traveling in this direction, okay, so he is traveling 5 meter in this direction. He traveled 5 meter. Now suppose he, for some work, he came back to this position. See, again traveled, he turned around 180 degree, and he came back to the initial position. So displacement is final minus initial position, right? So if you see, it is, this is the initial position and this is the final position, right? So this is equal to 0. That's why it can be 0, right? And how it can be negative? Suppose he traveled 5 meter more towards this west direction. So from the initial point, if you see, it is going in the opposite direction, in this direction. So that's why displacement, to represent the displacement, we are considering this is positive direction and this is negative direction. So I would write that the displacement would be minus 5 meter. This minus is indicating the sign, which is indicating that from the initial position it is going backward. Okay. So the total distance covered is the algebraic sum of all the distance traveled in the different direction, and but net displacement is the net displacement. Okay, but if you talk about displacement, it would be the net result or the vector sum of all the individual displacements in the different direction. For example, if I tell you by example, let us say A is started from this point. He moved in this point, then take this path, then he goes there. So 10 plus 5 plus 5 meter. This is the total distance. And if you talk about displacement, and if you talk about displacement, in this case, the displacement would be the net result. Okay, net result. So it would be in this direction, vector. So if you consider everything vector, so this is the resultant in the vectors, right? So if I consider this, put this direction and this direction along with their magnitudes, I would get this resultant from A to final position. Okay, there is always a distance covered whenever there is a motion, right? But displacement will be zero if the body comes back to its initial position, as we have seen in this example, right? The unit is same, in it is a meter, it is also meter. Now let's move to the next topic, which is speed. Speed says that what is speed? Speed is the rate of change in distance over time. So speed is a scalar quantity, which means it has only magnitude and no direction. Okay. So if I say speed is equal to the distance upon time. So distance itself is a scalar quantity. That's why speed is also a scalar quantity. It has no direction. Okay. So I can write this to this represent distance. We generally write delta s upon delta t, or if there is short distance covered, very short distance, then ds over dt. Or we sometimes represent it with x also, the distance. Then it's dx over dt. Okay. So it is representing the change in the distance or the total distance. I would say average speed. If we have to define the average speed that is equal to the total distance divided by total time. This would give you speed. Always remember, it doesn't have any direction, it has only magnitude. Okay, now let's see what is velocity. So velocity is the rate of change of displacement over time. So if I define velocity is equal to change in displacement upon time, right? Displacement can also be represented with the same notion like ds over dt, or we can write delta s over delta t, where delta s is the displacement. Okay, so we know that displacement is a vector quantity, then obviously velocity would also become a vector quantity. So velocity has the magnitude as well as direction. So for example, A is moving in this direction, suppose towards east. So we have to specify that the velocity, it is taking 5 meter in 1 second. It is covering 5 meter in 1 second. So I have to specify that the velocity of A in the direction of east will be 5 meter per second in towards east, right? So we have also have to specify the direction. The unit is same for speed as well as velocity. Just the difference is that in this we are taking displacement. Velocity is equal to displacement upon time, and speed is equal to distance upon time. So let's see the differences. Uh, the definition we have seen, it is a scalar quantity, so there's a vector quantity. Velocity is a vector quantity. It can be negative, it can never be negative or zero, because again the same concept, because the distance cannot be negative. If there is a motion, it cannot be negative or zero. But if we talk about the velocity, it can be negative, zero and positive. So if a person is traveling in this direction and comes back again to the same position, in that case displacement would become zero. So obviously the velocity would also become zero in that space. If it is going in opposite direction, then the velocity would become negative in this case, right? Velocity is directed speed. uh, so basically, it velocity is a special type of speed where direction is also added, right? Speed may or may not be equal to velocity. A body may possess different velocity but the same speed, right? So it can have at various moment, it can have various velocity. Suppose a particle is moving in a circular direction, covering the distance per unit time is same, but the direction is changing every time. So that is the example where velocity is changing every time but the speed is same, right? So a body can possess different velocities at different time but the speed can be same. So that example, you can understand from using this example. Now let's solve this numerical. A car travel along a straight road, okay, in east direction, for 20 meter, it is 20 meter, 20 meters in 5 seconds. Oh, it's 120 only. It's actually 120, right? Okay, so a car travel along a straight road to east for 120 meters in 5 seconds, then it goes towards west. Okay, so first he is traveling towards east, and then he turns back and travel 60 meter in 1 second. Okay, so this distance is covering in 1 second towards west. So this is the initial point and this is the final point. Let me represent it with different colors. So this is your initial point and this is your final point. So they are asking about the average speed and the average velocity. So let's first find out what is the distance he traveled. So the distance he traveled is 120 meter plus 60 meter. So it would be 180 meter. If you talk about displacement, displacement would be the final position, right, minus the initial position. If you see from the initial to final, this is your net displacement, right? This blue line is the your net displacement, right? Although it would be overlap, it would overlap because he's from this point he basically turns back and going towards west. But for the clarification, I made this round direction diagram. So this is not a slanting line or something, it is a straight line. Just go back to 60, right? So this is the point. So final minus initial. So I can say that 60 minus 0 is equal to 60 meter, right? Because if you name it as 0, it is 120 and between somewhat it is 60, right? So that's why I have written the if you position the on the basis of that, then you understand it. So basically I am giving this at 0 line, and this is your x value is equal to 60 and x value is equal to 120, like in the graph we draw, right? So this is the final position and this is the initial position, that's why we got 60. So the speed is equal to the distance upon time. So distance divided by time is equal to 180 meter, and velocity okay, divided by time. So time is 5 second plus 1 second, it would be 180 meter per second divided by 6. So it would be 30 meter per second. And if you talk about velocity, it would be displacement upon time. It would be, so in this case displacement is 60 meter and the time is 6 second only, so it would be 10 meter per second.